So good morning, everyone. Let's start with the day 2, the basic of security for your end-to-end program. Now we're going to start basically from the terminology itself called as security. Now what do you mean by security? The state of being free from danger or any kind of a threat is called as a security. For that we require a security. It applies to any vulnerable or any valuable asset. An asset can be a person, an asset can be a community, item, nation, or an organization. So this is the basic definition of what is security. Now the question comes is, why do we need security? We need security basically to protect your vital informations while still allowing access to those who need it. That means we need to protect our asset or any person or any file so that any unauthorized person cannot access that particular file or the person or something like that. So it protects your vital information but still allowing the access to those who actually need it. We provide the authentication and access control for the resources, like we're gonna give a username and the password for that particular person or the user who is going to access that particular file. And we'll give the access control for that resources, like the privileges, what you can do after that. And we give guarantee availability of the resources, like 5 nines that we have already discussed about that, for the reliability. Basically, your security categories are divided into a broad picture, like there is an immense literature on the analysis and categorization of the security. So basically the security categories are IT, physical realm, and the political. Now we have airport security also, corporate security, home, physical security, port security, and so on and so forth. National security, public security, internal security, international security, human security. But the one which we are going to focus is your IT one. In this curriculum, we're going to talk about the computer security, internet security, data security, network security, as well as endpoint. And we do have other features also like information security, application and communication security, which comes into different certifications. Now, what is a computer security? At a very layman language or at a very simplest level, a computer security is a technique used to protect the data stored on a single computer only. This type of protection ensures that the data or information stored on your computer cannot be accessed, read, or otherwise compromised by any individuals without appropriate authorization. What I mean by that, you have a computer, everyone should have a computer, and let's say for example we have given what the password for that. So when you are protecting your PC, it can be a BIOS password or it can be an OS password. Whenever you are giving a password for that particular computer, and if you have installed the antivirus over there to make sure that none of the malware is coming into that particular PC, we call that kind of a security as a computer. That means only one individual computer is getting secure. That kind of a security comes under the IT realm category, is called as a computer security. Only one computer. Huh? Now, what is a network security? Whereas computer security protects only an individual computers, network security is the measure taken to protect your own network. Network security is designed in such a way to prevent the attack of the common network attacks or hacks, like from the virus, worms, and other transferable issues, adwares and the spywares, hackers, service attacks, data and the material theft, or any identity theft over there. So basically network security is to protect your network, and network comprises of your multiple networking devices like your routers, switches, multiple n number of devices can be there in your network, and we are going to protect those all devices from the common network hackings. Threatscape overview. No industry is exempt from attack. If anyone is saying that, or any organization is saying that we are 100% threat free or something like that, it's not a correct statement. Everyone, individual person, organization, nation, any user person, everyone. So no one in the industry or the industry is exempt from the attacks. Now, who is your attacker? Attacker can be an individual identity, individual person. It can be a small team of hackers. It can be an organized crime that has been launched. It can be from the national government also, who can do that. Attackers are creative thinkers. So I usually say in all my lectures that a good security specialist will be a good security specialist only when he start thinking in a way of a hacker or an attacker. So attackers are very creative thinking. Combining with the old way of attacking or hacking with the new concepts, attackers are very creative nowadays. So it's good. Now, before moving further ahead in your CCIE security world, right, we need to understand certain terminologies. Like, what do you mean by the word called as vulnerability? What is a threat? What is a risk? An exploit. I gotta start from the word called as a vulnerability. As you see on the right side in the diagram itself, there is a wall, but in the wall there is a loophole. Now try to understand from this picture itself what I mean by that. So vulnerability, whenever it comes into your head, always think about a weakness. So vulnerability is a weakness that can be exploited by an attacker to perform an unauthorized action within a computer system, or maybe a vulnerability can be there in a network also. To exploit a vulnerability, an attacker must have at least one applicable tool or technique that can connect to a system's weakness. So if you have a weakness in your system, you require a tool to get into that system via that particular weakness. There are multiple types of vulnerabilities are there. It can be a physical, it can be a natural vulnerability, it can be a hardware and software vulnerability, and in our curriculum we gotta talk about the hardware and the software, both types of vulnerability. It can be a media, stolen, damage and disk tapes, communication vulnerability. And the last, humans are also what, having certain weakness. So these all are the different types of vulnerability that is existing as of now. Our main criteria and main agenda will be there to secure and see the vulnerabilities and the weakness in your network, in your devices, or on the computer devices and host devices. So when the word term vulnerability comes, always remember we are talking about the weakness. Next, exploit. So the mechanism or a tool used to take advantage of the vulnerability in order to compromise the security or the functionality of a system. So what we have just done it, we have a network, in that we have a vulnerability, there is a weakness. So mechanism or tool used to take advantage of that weakness in order to compromise the security or the functionality of a system is called as exploit. So if I'll go back to the previous slide, what is vulnerability? It's a weakness which can be exploited. Exploited whenever comes, it means that tools can be used by an attacker to perform the unauthorized action within a computer system. For example, a sequence of commands, a piece of software, or a chunk of data that can be used to exploit the weakness of the system. Threat. Event or circumstances which cause damage to the system could exploit the vulnerability. What are the threats? It can be a natural, it can be an unintentional, it can be an intentional also. So we have different types of threats are there. So whenever a weakness is there in a system by which an attacker can exploit it, that means for that system there is a threat. Risk. The probability of a threat or an event to happen. Like there is a risk for this particular system, 99% this is risk free, but 1% risk is there that on this particular system attacker can exploit the weakness, so there is a threat to this. The security risk cannot be completely mitigated, but yes, up to a certain extent we can do that. Coming back to the goals of security. Now what do you mean by the goals of security or the network security? Whenever it comes to the network security, do remember that we are always going to talk about CIA. Now what I mean by that? If you see closely to this particular picture, in middle we have a data. So for that particular data, it has to be have a confidentiality. It has to be has an integrity to that, and it has to be have an availability. Now let's understand these three words and the terminologies. When you talk about the confidentiality of a particular data, what do you mean by that? The first goal of the network security is confidentiality. The function of confidentiality is in protecting precious business data in storage or in motion from an unauthorized person. Now, there are certain confidential documents are there. Now, what I'm trying to say here is, The document which is confidential for me, it is not mandatory, it is confidential for you also. Like say for example, my PPTs, my data. It is valuable for me, but the very same data is not valuable for my dad, to be very honest. So what do you mean by how we define that particular device, that particular data, or that particular document is confidential? It depends from person and organization to organization also. When you talk about the confidentiality, you are saying that in any unlegitimate person or any unauthorized person should not access that. It should be accessible only to the legitimate or authorized person over there. So confidentiality part of network security makes sure that the data is available only to intended and the authorized person. That is your what? The confidentiality. Then comes what? The integrity. Integrity aims at maintaining and ensuring the accuracy and consistency of the data. The function of integrity is to make sure that the data is accurate and reliable and is not changed by an unauthorized person in transit. Let's say, for example, source A is your Bob and destination B is like Alice. In between them, there is a communication going on, and they are trying to say that, and Bob is trying to say, Alice, I'm doing good. When we talk about the integrity, that means in transit, when this communication is going on, a third person should not come in between and do certain changes with that. Let's say, for example, if anyone changes, I am not doing good. He added a word called as not. That means there is an integrity issue in this particular data. So when you talk about the network security, the data should be confidential, and when the data is passing from point A to point B in transit, there should be an integrity that needs to be dependent on that. That means should not be any change. The function of integrity is to make sure that the data is accurate and reliable, and it's not being changed by an unauthorized person or hackers in transit. Availability. Now, when you are trying to give for your network the confidentiality as well as integrity, what's the point if that network is not available 24/7? So our task will be that first, whenever you talk about the network security or any kind of a security, first thing is almost is what? How the availability of that XYZ thing. It should be 24. Once that asset which you are trying to have it, once you are trying to save it, right, once that is available 24/7, then only you will provide the confidentiality and integrity for that particular system. So the function of availability in the network security is to make sure that the data, the network resources, or any network services are continuously available to the legitimate users whenever they require. So it has to be 24/7. Now, by seeing all these three things, we can say that the security, network security goals are confidentiality, integrity, and the availability. Your network resources or network services should be available 24/7. If it's available, it should be confidential to the legitimate user, and if any data is transferring in the network, we should provide an integrity for that, so that there should not be any changes in the transit. Asset. Now, when we talk about an asset, what do you mean by that? What are we protecting exactly? So asset is a useful or a valuable thing. It can be a person, it can be an organization, it can be a person of an organization. In order to provide the appropriate level of security to an asset, why we are protecting the asset? Because this is a very good question, and now we are going to link all the slides that I have already taken. Why we are protecting the assets? Because they are what? Vulnerable. So because the vulnerability is there with all the assets, we need to protect them. How? We can provide the network security with respect to our curriculum, if I'm talking. We can provide the computer security, application security, and so on and so forth. Now, saying this, you got an idea of certain terminologies. Let's move further ahead and talk about there are different types of attacks out there. The first and the foremost, the most common, which is nowadays completely, I'll not say completely, but it's kind of obsolete from the market. The first one is called as denial of service. Now, let's talk about what is a denial of service. Denial of service purpose is to shut down a site, not to penetrate it. Now, when I talk about to shut down a particular site, what I mean by that? Let's say, for example, I have a server. What is a server? First of all, let's understand that. What is a server? A server in a layman language is nothing but a device which provides what? The services. Services to the client. As simple as this. Now, when you talk about the servers are having certain resources, valuable resources. Now, what are the resources of a particular server? First, the CPU is required. Second, RAM is required. Third, the storage is required. And fourth, you require an adapter to connect with that particular network. These are the mandatory. There are many multiple resources are also there, but these are the mandatory ones which are called and considered to be as important resources for a particular server. Now, what are the different kind of servers do we have? I'm talking with respect to the services, not with respect to the company's model. When you talk about an application, like the way we have what the network, when we talk about the network, we have a three tier of what? Hierarchy is there for the network. Like we have a core, we have distribution, and we have an access. In a very same way, the application, what is an application? It's a tool that has been designed for the client so that they can access their services. Now, application also, for any application in the world, it is also being designed in a three-way of hierarchy or three-tier of hierarchy. What are those? Web, app, and DB. So whenever you are coming to any of the servers, any of the application, you're going to first hit the web servers on the port number 443 because it has to be secure over HTTPS. Let's say, for example, take for the Facebook. Whenever you try to log in the Facebook, you start with what? HTTPS www.facebook.com. That means at that particular moment, from that client PC, you are going to the Facebook server. But which server? The server which is providing the services of web on the port number 443. So once the authentication, username and password you have given, you'll move to an application server and after that to the database servers. Now, what is my agenda? Why we are discussing about this? What is a DOS attack? DOS attack means what? Whenever you are doing this client and server relationship, there will be like TCP and UDP handshakes will be there, TCP three-way handshake. Whenever the TCP handshake is going on, right, it's a three-way communication, right, like this. Now, client always trying to approach a web. Now, what I'm going to do is, as a DOS attack, if I'm an attacker, I'm going to send so many requests to this web server of the Facebook that it is going to consume all the resources. Now, at the end of the day, when the actual legitimate user is trying to hit that facebook.com on its web server, when all the resources are already being utilized, the web server is not able to open for that legitimate user. That's the main purpose of DOS. So purpose is to shut down a site, not to penetrate and steal any information. Denial of service, the name itself is denial of service. Now, what is a service? It depends what kind of a server you are using and what services you are running on top of that particular server. Now, saying this, attempt to make a computer or a network resources unable for the intended use, consume all the critical resources. So that is what we call about a DOS attack. It causes a system to crash once all the critical resources has been consumed. The system is going to crash out because the resources are not available for the threading. Now, saying this, it is considered to be a major risk, but nowadays it's being kind of obsolete. The major examples, you can Google it out, what is TCP SYN flood as well as ping of that. Now, to understand TCP SYN flood, I basically understand people what is TCP three-way handshake. I know most of you guys already know about that. Let's take a quick recap for that. So what is a three-way handshake? Before the sending devices and receiving a device start the exchange of the data, both devices need to be synchronized. During the TCP initialization process, the sending device and the receiving device exchange a few control packets for the synchronization purpose. And this exchange of the packets for the synchronization purpose in TCP called as three-way handshake. Now what is step number one? Send. Now device A, I have a client. Okay, let's assume that there is a client over here, right? And there is a device B, which is my server. On a very generic overview, client always reach and approach for the server. So there is a synchronization packet with the bit on will go, and this is not the acknowledgement, so the bit for acknowledgement will go 0. Along with that, there will always be an ISN number. What do you call that? Initial sequence number. It's a randomly generated value. If I'll show it, an initial sequence number is a random sequence number generated by the client allocated for the first packet in the new TCP connection. Now, what I mean by this is, if I'll go back to the diagram, I have a client PC. Let's say, for example, this is a huge number. Right now, I'll just use a simple number. Let's say, for example, 24. This is an ISN initial sequence number with the send packet. It has been sent to the server. If I'll just show it over here in the next Wireshark output over here, I've taken this from the omniseq.com. This is your TCP. The source port is a random port number, but I'm trying to reach to my server on HTTPS. That's why the port number is 443. Over here, this is the source port, this is the destination port. I can see that this is the sequence number, and this sequence number is called as an ISN. Let's say, for example, in my example, I've taken this number as to be as a 24, so that I can easily do a calculation on that. It's a huge number over here. If we check out the flags, all the flags are set to be 0. Only one flag has bit on, that is 1, which is your SYN, because this flag is your SYN flag. What is the step number 2? Once this SYN packet has been received by the server, this is my server, he received a SYN packet as a bit on, right? And he got an ISN number of 24, right? And now what happens is the server is going to send one acknowledgement to the client. But this acknowledgement considered to be a SYN also, synchronization. I am also initiating the synchronization with the client. That's why SYN bit is also on. And because he has to revert with an acknowledgement to the client, it bit is also on. But here, how this particular client will come to know that whether I am getting the response or the acknowledgement from the correct server, not from a rogue server, by seeing the one more, what you call about that is acknowledgement number, and that acknowledgement number is nothing but appended by 1. That means the number this client has sent to the server, server is just going to add 1 over there. That means 25. If this client is getting an acknowledgement number 25 over there, because he has sent 24 as an ISN number over there, he'll come to know that, boss, I get it from where? The legitimate server, not from a rogue server. So if you see the Wireshark over here output, I have the very same thing. The source port now becomes a 443. The destination port is still the same. And over here, this is the acknowledgement number over here, which I was talking about. And you can see the acknowledgement as well as SYN bit is on. But before doing this and moving further for step number 3, the server also send one ISN number to the client, because this is the first time the server is trying to communicate with client. That means, let's say, for example, this number is 64. So in the last step, step number 3, what happens is the client is going to revert and send the acknowledgement to the server by setting the ACK bit on, plus whatever the initial sequence number, that 64 that the server has sent to the client is just going to append by 1. 64 plus 1 is 65. So server is seeing this value. Why? Because again, very same thing. How server is come to know that I got the acknowledgement from the client, which is not an attacker, which is not an hacker. It's a legitimate client to whom I've sent the SYN packet. So this is basically your what? A 3-way handshake. Now let's talk about how it works over there. What is a TCP SYN flood? A SYN flood attack works by not responding to the server with the expected acknowledgement code. The malicious client can either simply not send the expected acknowledgement, or by spoofing the source IP address in the SYN, causing the server to send a SYN ACK to a falsified IP address, which will not send the acknowledgement because it knows that it never sent a SYN. In an attack, the half-open connections created by the malicious client bind resources of the servers. Now, what I mean by this SYN flood, I have a client over here whose IP, let's say, for example, is 1.1.1.1. I have a server, a web server over here, right? And I have an attacker over here. Now what happens is, let's say, for example, this is Nitish. My IP is, let's say, for example, 2.2.2/ whatever, 24. I have spoofed. Spoofed means changed, wrong, falsified IP and I have taken the victim's IP 1.1.1. What happens is, now I'm going to send with the spoofed IP the SYN packet to this particular server with the SYN bit on, right? And let's say, for example, whatever the initial sequence number that he sent is 24 over here. The web server receives the SYN packet over here. What is going to say, server is going to do? Server is going to send the SYN plus ACK message with a 25 bit over here, because it has to be appended with its own initial sequence number, that is 64. Once this has been received by the client, what happens is client will say that, boss, I'd never sent the SYN packet to you. And this 25 also, I doesn't know that. So this is a half open connection. But what happens with this? The server is using the critical resources over there, because it receives a SYN from a fake ID, from the falsified IP, and he is sending what the SYN act. So this connection is open over here. It's half open, and it is using the resources over there. So what is going to happen? Like this, if I can send multiple spoofed IP SYN packet to this particular web server, it is going to one day consume all the critical resources of that server. Now, if any legitimate user, let's say for example Bob, he is trying to access this particular web server, once the critical resources are already being consumed, this web services will never, this server is never going to respond to the Bob. And what we have achieved by this, we have shut down the services. We have shut down the services of that particular server. So this is the main agenda of your DOS. So at this particular point, the server cannot connect to any of the clients, whether legitimate or otherwise. This effectively denies the services to the legitimate client. Some system may also malfunction or crash when other operating systems functions are starved of resources in this particular way. MAC flood attack. In a way, we have done what? Spoof the IP address. In a very same way, we can spoof the MAC address also. A switch learns a MAC address. Now, how the MAC flood attack happens? I have a switch. A switch has a main advantage over other devices comparatively to the hub is it is bit intelligent. It learns the MAC address, correct? Learns the MAC address. Now, let's say, for example, I have a client PCA. It connects on an interface over here. What happens is the switch is going to learn the MAC address. We are not getting in that how a switch learns MAC address, but assume that a switch learns a MAC address on 1/1 on a VLAN number 10. I have one more hacker over here. He has spoofed the MAC address. Now, like this, there are multiple MAC addresses that the switch going to learn. What is the DOS attack on the switch with respect to this? Every switch have a limited memory to store the MAC addresses. Like at access layer, there are different products. They can store up to 20,000 MAC addresses or 50,000 MAC addresses, and so on and so forth. When you go on to the upper of this particular hierarchy of this tier, like at the core layer, you will see that it can consume to 1 lakh MAC addresses. Our agenda as an attacker will be the switch. Let's consume all the resources of that switch. Let's consume the entire MAC table, right, CAM table of that particular switch, so that any legitimate user is coming, the switch is not going to learn the MAC address. Why? Because its CAM table is already full. So what is going to happen at that particular moment? Switch will always start flooding on all the ports in that respective VLAN. This is called as MAC flood attack. Next, what is the DDoS attack? DDoS attack is basically your what? Distributed denial of services. Distributed denial, once we talk about distributed denial of services, we think that there could be now multiple attackers, because in this denial of services, maybe only one user is working on. Distributed denial of services attacks use the multiple computers and the internet connection in between to flood the targeted resources. DDoS attacks are often global attacks. On this particular example, if you see that, I have one attacker only. But it has taken a control over all the PCs with respect to a controller, only one controller, or to whom this attacker is controlling. And while this controller, I'm controlling multiple devices. Because there is no state of these particular devices, we generally call in the security world these PCs as what? The zombies. These all are what? The zombies which is present over there. And with the help of these PCs, now I'm going to do what? Distributed denial of services. I'll open the TCP connection for this particular web server, and it has become a victim for me. This is also called as a botnet. And now the question is why this is distributed denial of service is also called as a botnet attack. Let's see that. So why this is called as a botnet? Botnet consists of group of zombies computers that run as a robot. And the last three words or letters of this particular word we have taken as a bot because they are acting as a robots. So that's why this is called as bot attacks. So a master controller mechanism that provides the direction and control for the zombie. So there will be an attacker. An attacker is going to connect with the controller over here, and this controller is going to connect with all the zombies or the robots, right? And they are going to perform for this particular attacker who is sitting at the back. So this is your basically a botnet attack. What is spoofing? Spoofing, I believe we already know about the spoofing. Injecting traffic that appears to be sourced from a system other than the attacking system itself. I can spoof my identity. I can spoof my IP address. I can spoof my MAC address. It's not an attack. Spoofing is not an attack in itself, but it is a technique that can leverage in various types of attack. Like type of spoofings are IP address spoofing, we have discussed, MAC address spoofing, and so on and so forth. So applications of the service spoofing like DHCP, DNS, email, we're going to talk on this, all these particular types of spoofing attacks in the latest part of this section. This is your IP address spoofing. We have actually spoofed the IP address of the legitimate server. In a very same way, I can change the MAC address of my system also. On the Windows PC, if you talk about IP config on CMD, how to change the MAC address of your system, you can go and edit your Ethernet adapter, go to the properties on the advanced tab, you got an option, you can change the MAC address. On the very same way on the Mac PCs also you can change by going to ifconfig and check your adapter, and whatever the adapter is there, you can give a command sudo ifconfig en1 ethernet 1 on that particular, whatever the MAC address you want to put it over there, you can put it. Very important point, all these things, MAC address spoofing is a temporary. Once the device is restarted, the MAC will be restored back to the factory default setting, which is your burnt-in address. Reflection attacks. Now, what is reflection? Two words usually comes together, reflection as well as amplification. In a reflection attack, the attacker sends request packets with the spoofed IP address to get other hosts to a victim, to flood a victim. The reflection attacks can be an amplification attack if the request packet solicits a larger response. In an amplification attack, the attacker sends small forged request packets to at least a large reply, and reflection and application attacks are harder to trace because the actual source of attack is hidden. Let's see for this particular diagram. I have an attacker. What is the reflection? If any of the light, if you put it on the mirror, it is going to get reflected. In a very same way, attacker, this is an attacker, it has actually spoofed the IP address and it is sending the wrong messages to the correct NTP servers, and this NTP server is going to send to an answer to that particular victim whose IP is getting spoofed by this particular attacker. So it is getting reflected, plus how it is getting amplified. I keep on sending the request to the different NTP servers, and it is getting amplified again and again for this particular victim. Talking about next is social engineering attacks. Now, I believe most of you know about this, but let's talk on generic overview of the social engineering attack. There is a process how it happens. The first is information gathering. I'll gather information about you. I'll develop a relationship with you. Once I know about the relationship with you, I'll try to exploit the vulnerabilities of this relationship, and then I execute to achieve my objective, whatever my objective is there. So the people manipulation, what is social engineering? It's a people manipulation in order to gain the benefit. You can see that the shoulder watching happens nowadays in the ATM machines when you go towards near to your ATM machine, when you're trying to put your card pin. Attacker watches you as you type your password or the card pin number over there. You may get a phone calls from a different fake identities saying that, boss, I require your sensitive information like your bank details, like your credit card number, CCV number, or maybe your expiry date. You can get an email from the different vendors saying that, boss, you got a one crore $1,000 or $1 million, what do you call that, lottery ticket you have achieved. We just require your bank details so that we can put it over there. Like these kind of attacks are called as basically a social engineering attacks. Nowadays the latest one is USB memory stick lost on purpose on the public platform, and what users does is they take that particular pen drive and they attach to their system. There will be a malicious code present in that particular USB, which is going to harm your system over there. Now, what do you mean by the term called as phishing attacks? One of the most commonly used types of attack. It is based on people's vulnerability, weakness. In order to be successful across years, it has changed its method. The phishing attacks are email based, on the DNS farming based, on the basis of phone calls, or smishing, which is on the basis you may get a fake or falsified SMSs also. Saying that, next is your password attack. What do you mean by the password attack? This is what methods of obtaining the password. It includes guessing. You can guess a particular password. Let's say, for example, I have my best friend. I know that his password is his girlfriend's name. So I can guess it, right? You can guess the different things over there. Brute force attack as well as dictionary attacks. What are these two attacks basically? Now there are certain tools available in the market, right? When you are trying to hit with that tool to a user, legitimate user, and you are trying to crack the password, you are trying to guess the password. Now most of the time you have seen that the password are your basically can be a what do you call that, a name, right? Or it can be a word which will be present in the dictionary. So all the dictionary words will be present in that 12, and one by one it is going to check, and once it gets checked, it's good and good for that particular attack. What is brute force attack? Nowadays we just don't take a name like morning. This not will not be your password. Nowadays we are using the combination like alphanumeric characters or the numbers, right, or special characters like this. So whatever the most used, commonly used worldwide, your password could be, your password could be your QWERTY. It says you can see your keyboard right now. QWERTY we call as this. It's not a dictionary word, but this is a well-known used password. Your ASDQWE or ASD. There is no word, but it's a combination of 3 rows. These all are the different types of combinations collected over in a tool along with the dictionary words. And when you attack for a particular system, that is called as a brute force attack. Example of a brute force attacks are like, let's say for example, that's why in the bank nowadays they say that to lower down this particular attack, if you go to the bank, they will ask you to use your password as one as a lower caps, one is uppercase, one should be a special character, there should be a minimum length to that particular password, and so on and so forth. This is one of the examples that I've taken from the Google itself. You can see that this is kind of a brute force attack. I'm attempting a target, let's say for example 192.168.254, 134 over there. The username is the administrator, but I'm keep on trying the different words over there. It might possible can be a dictionary word, or it can be a combination like 212121. It can be different combinations that has been used over there, and in the last it keeps on going. It keeps on going until unless it finish all its words or the letters or the combination of different words with the alphanumeric character. Once it has been done, so you can see that it will give you a green signal, boss, that I have logged in that particular device. Now you can do whatever you want to do. Next is called as mem attack, which is called as man in middle attack. You can see this particular diagram itself, that man in middle attack usually breaks what? The integrity of a data. From source A to source B, if the traffic is going man in middle attack, that means in middle, in transit, I'm going to manipulate the data or steal the information. Let's understand this. It's a generalized concept that can be implemented in many different scenarios. Attacking system imposes itself in the communication path between two other systems. Normally involves attack against the networking protocols such as ARP, DNS, and IP routing protocols, resulting in the misdirection of the traffic. I hope you got an idea what I'm trying to say. Man in middle attack. If the route information is going from point A to point B, or router A to router B, I can easily manipulate the routes also. I can easily manipulate the ARP request and response also. The basic important point here to understand is what are the two types of man in a middle attack. One is called as passive attack, another one is called as an active attack. What is a passive attack? Attacker steals the confidential data or the information. But the active attack is it steals the information. Along with that, it modifies the data in transit or injects the data of its own choice. So this is basically what your man-in-middle attack with active as well as passive attack. Now coming back to an important terminology called as malware. Let's understand that. What is a malware? So basically a malware is a malicious software. So whenever you see a word called as terminology as a malware, you understand it is what the malicious software that comes in a different and several forms. It is basically a code or a software that is specially designed to damage, disrupt, steal, or in a general inflict some other bad or illegitimate action on the data, host, or the network. 99% people think, or many PC users considers malware, virus, spyware, adware, worm, Trojan, etc. are all the same thing. While all these infections harm your computers, but they are not the same. They all are different types of malicious software that are each behave differently. The word malware is a combination of what? Malicious software. So it's a generic term used to describe all of the hostile and intrusive program codes, including virus, spyware, worm, Trojan, or anything that is designed to perform the malicious operations on your computer. Malware cannot, this is very important line, the malware cannot damage, because malware itself is a software, it cannot damage the physical hardware of a system or any network equipment, but it can damage the data as well as the software residing on the equipment. This is the overall hierarchy. Malware is the overall terminology. It's a malicious code that comes in a different form. There are different types of malware. One is your virus. So virus is a type of a malware. Worm is a type of a malware. Trojan is a type of a malware. Right? It doesn't mean the virus and worms are same thing. Now, what's the difference between them? Let's understand that from the word called as virus. As you can see in this particular diagram, right? What is a virus? When we talk about a viral fever also, what is happening? That virus of that fever is actually reflected in your body. In a very same way, if I talk about a virus, and I'm going to start with the biological term itself, just as a biological virus replicates itself in a human cell, a computer virus replicates itself in computer memory when initiated by the user. This is a very important line. Initiated by the user. Not only they replicate themselves, but may also contain some malicious codes, can affect your files, it can affect your files, it can affect your OS, or even your MBR, which is used for booting your operating system, thereby making your computer start slow or not boot at all. Almost all the viruses are attachable with .exe file. You have seen that executable file, which means the virus may exist on the system, but very important, will not be active or able to spread until the user runs or opens the malicious host or file or a program. That's why the virus has to be initiated by the user. It comes with a different software. Let's say, for example, you have bought your VLC.exe file, right? When you download from any torrent or something like this, right, when you try to install that on your system, so virus comes along with this. So unless you are not going to install the VLC, the virus is also not going to get installed. So virus is initiated by the user, but it will not be active or able to spread until a user run or opens the malicious host file or the program. When the host code is executed, the viral code is executed as well. Normally, the host program keeps functioning after it is affected by the virus. However, some virus overrides other programs with the copies of themselves, which destroys the host program altogether. Saying this, if I'll move further ahead to the worms. Now, what do you mean by the word called as a worm? Let's understand that. The name itself says that computer worms are pretty similar to the virus in that they replicate functional copies of themselves and can cause the same type of a damage. It's pretty similar to that. In context to the virus, but it's similar, but there is a certain differences, which requires, in contrast to the viruses, which require the spreading of an infected host file Worms are standalone server. It doesn't come with the vlc.exe file. It's a standalone server. It's a standalone software and do not require a host programmer or human help to propagate it. To spread, worms either exploit. Now you know the word called as exploit. Now you know what is a vulnerability. So it either take a tool to get into a weakness of a target or targeted system, or use some kind of a social engineering, or any attacker will be asked you to install by social engineering that please install this particular software. Once done, it is going to work at the back end. A worm enters a computer through a vulnerability in the system and take advantages of the file transport or information transport features on the system, allowing it to travel unaided. Talking about next is Trojan. Now, what's this Trojan? Trojan is another type of a malware named after the wooden horse the Greek used to inflate as a Troy. It is a harmful piece of software that looks legitimate. Users are typically tricked into loading and executing it on their systems. After it is being activated, it can achieve any number of attacks on the host by irritating the user by popping up the windows or changing the desktop, changing the time, damaging the host, deleting the files, stealing data, or activating and spreading other malware such as viruses. So if I'll just compare these three as if now virus, worm, and Trojan, right? Virus is comes with a software, legitimate software along with .exe file, right? This is your another code, another malware, and it gets replicated. Worm comes as a standalone software. It comes as a standalone. It doesn't comes in a different way, and it also gets replicated. And Trojan is again a standalone software, but it does not get replicated. This is the basic differences between the virus, worm, and Trojan. Trojan are also known to create a backdoors to give the malicious user access to the system. Unlike virus and worms, Trojan do not reproduce by infecting other files, nor they self-replicate. Trojan must spread through user interaction, such as opening an email attachment or downloading or running a file from the internet. Talking about now next is what is spyware and adware. Spywares are also malicious computer programs that can be installed on computer, but unlike any of the above one or the previous one like virus, worm, and Trojan, they don't harm your computer in any way. Instead, they attack you directly. Once installed on a system, they run in the background and keep on collecting the user personal information or the data. These data can include your credit card numbers, your CCV number, your passwords, your important files, and many other personal stuffs over there. Spyware can track your keystrokes, scan and read your computer files, snoop your the IP chats as well as your emails also. Therefore, again, it's always advisable to download and install the software from the trusted source only. Spyware is any software that utilizes a computer internet access without the host knowledge or explicit permission. According to the certain experts, approximately 90% of the computer in the worldwide have some form of spyware aids in gathering the informations, browsing habits. What they actually gather, like the browsing habits, site visited, links clicked, etc. Data entered into the form, including your account name, account password, account details, text or the form of web-based email or etc. So in this way, as of now, we have seen the types of attacks. We have got certain idea about what are the different things are there, terminologies. We have seen all this. So in the next lecture, we're gonna start with the cryptography techniques. I hope you enjoyed this particular session, and we'll see in the next class, day 3, which is all about your cryptography. Thank you very much.